All right, let's just dive right in. We usually think about data as just a big pile of individual facts, right? But what if the real magic, the most powerful insights, aren't in the facts themselves, but in the hidden connections between them?
I mean, really think about that. With all the data swirling around us every single day, what crucial patterns are we, and even our smartest AI, totally missing? Just because they're hiding right there in plain sight. That's the big question we're going to unpack. So, to get this, we first have to talk about the limits of just looking at information piece by piece. You see, machine learning models, well, they're a lot like us. They can completely miss the bigger picture if they're only staring at one isolated fact at a time. And that is a huge problem for AI. Because, let's be honest, the real world is messy. The connection between two things is almost never a perfect, straight line. It's complicated, it's interactive, and raw data all by itself just can't see that kind of nuance.
Here's a super simple way to think about it. The word weekend, that gives you one idea. The word rain, that gives you another. But you put them together, rainy weekend, and boom, a totally new concept just pops into existence. It changes your plans, right? It changes your mood. That combination is way more powerful than the two facts standing alone.
So, how do we teach a machine to make that same kind of intuitive jump? To understand that sometimes A plus B creates a totally new thing, C. Well, this is where the Funchik solution comes in.
And the answer is this brilliant and actually kind of simple technique called feature crossing. This is the secret sauce that data scientists use to build much smarter, more intuitive models.
So what is it really? At its heart, feature crossing is just the process of creating a brand new data feature by combining ones you already have. You're basically leaning over and telling the model, hey, pay attention to how these two things work together. It's how you spell out those connections we've been talking about. And how it works can be surprisingly simple. Like, if you have two numbers, say age and income, you might just multiply them up. Or if you have two categories, like our weekend and rain example, you can literally just pair them up to create a new combined category. You're inventing a feature that actually represents a real-world interaction.
Okay, I know that might still sound a little abstract. So let's walk through a really common example that'll make this whole idea just click. It really shows how you can build a much richer picture of the world.
Okay, so imagine a model has two bits of data, a person's age and their income. Now, on their own, they're pretty useful. But when you cross them, let's say by multiplying them, you create an incredibly powerful new feature. The model can now understand something much, much deeper. For instance, a 25-year-old making $100,000 a year is probably in a very different life stage with totally different spending habits than a 55-year-old making that exact same salary. That insight, it's only possible because of that crossed feature.
And that one example really gets to the heart of why this technique is so important in modern AI. It is not just some clever little trick. It delivers huge payoffs when you're trying to build models that actually work.
It really boils down to three key benefits. First, it explicitly models these interactions, which helps even simpler, faster algorithms see complex patterns they'd totally miss otherwise. Second, and this is huge, it dramatically improves the model's predictive power because it captures those messy, real-world relationships. And third, and this one is my favorite, it lets a data scientist inject their own expertise, their own human intuition, right into the model to guide it towards the connections that actually matter.
So at the end of the day, what is feature crossing really doing? Well, it's elevating a model's understanding from just flat, two-dimensional facts into a rich, three-dimensional insight. It's like you're handing the machine a pair of 3D glasses. All of a sudden, it's not just seeing a bunch of scattered dots on a page. It's seeing the depth, it's seeing the structure, and it's seeing all the complex relationships that connect everything together.
And that's really the crucial point. This isn't just some math trick. It is fundamentally about teaching a machine to see the world a little bit more like we do, to finally understand that the whole is so often greater and way more meaningful than the sum of its parts.
Kind of makes you wonder, doesn't it? As we get better and better at showing machines how to find these hidden links, what incredible, unthought of connections are they going to start to uncover all on their own? Thanks for joining me for this explainer.